Hi everyone, welcome to my tutorials on variant effect prediction with SNPEFF. In today's tutorial, I'm going to show you how to build a custom database. So for this tutorial, I'll show you how to build a custom database using Genbank files. Instructions for building a database can be found on the SNPEFF website. So there's a page, and I'll leave the link to this page in the description box. Now, before you attempt to build a database, just make sure to check what is available, and then if, let's say, you check and then the information you're looking for, i.e. the organism you are dealing with, cannot be found, then you can build your database. All right, so we are going to take a look at how to build a database. Now, with the instructions here, let's check. You go through all of them, by the way, on the terminal, but I just thought I'll bring this up. Let's just scroll down. So to build a database, you first need to configure a new genome, which we will do. Then you add the entry and then add a codon table parameter, and then you can build a database using gene annotations and reference sequences. So there are different options available. You can use any of these 4 options, but for this tutorial we are going to build a database using Genbank file, because the data we are going to use is for a smaller genome, a small genome. All right, so we don't need to use the DTF for the GFF file or this one. All right, so I repeat, if you are dealing with a small genome, then you can just use option 2, all right, so that you don't complicate your life. So that's what you are going to do. So what you need to do is to make sure that you have SNPEFF installed, and you should also have VCF tools installed. The instruction for installing the tools can be found in the description box. So now let's get started. Okay, I'm on the terminal now. So what I'm going to do next is to create a working directory, and then I will cd into it. So I'll say make the variant effects, and then I will cd into it. So that will be cd variant effects. Okay, now I'm going to download the SNPEFF binaries. So let's go to the download page. This is the page, and I will leave the link to this page in the description box. So here we are going to download the latest, so we will use this link here. So because I'm going to download on the terminal, I'll get a download link, but you can also click it. All right, so I'm going to get a download link. So I'll right click, and then I'll click on copy link, and then I'll move to the terminal, and then I'll download it. So I'll say wget, and then I'll paste the link there. So let's execute this command. All right, so the file has been downloaded. It's a zip file. So after it has downloaded, we will extract the contents. Okay, the file has been downloaded. So let's do an ls. We are going to find it here. So now we are going to extract the contents. So I'll say unzip, and then I'll supply the file name. So let's execute this command. All right, so we can see the activity. Now we have extracted the contents. So I'll clear the screen first. I'll do an ls. I'm going to find this directory, SNPEFF. So you can ls into it, and then you find some directories and files. All right, so we have our jar, we have this, we have this, we have all of these. All right, now let us do a quick test. So this is what I'm going to do. I'm going to run SNPEFF. This is a Java file, so that means I need a Java. All right, so the quickest way to check if you have Java is to type Java, and you can even say dash version like this. So let's execute this command. So I'll execute it, and then if you should have Java installed, then you have some information displayed for you. All right, alternatively, you can install SNPEFF using Anaconda or Mamba or Mako Mamba. All right, but just make sure to have Java installed, and then download the Java file. So this is a quick info about how to set SNPEFF on your system. Okay, so let's do this. Now we have SNPEFF downloaded, so let's also download the example data. All right, now before we even download the example data, let's just do a quick test on SNPEFF. So I'll just say java-jar, and I'll say SNPEFF slash SNPEFF.jar. All right, so if I do it, I'm going to get this text being displayed. So once we have this displayed, that means that everything is okay. So that's it. Now let's proceed. Let's clear the screen. Let's do an ls again and then proceed. So what we are going to do next is to download the example data that we are going to use. So we can find the data here. Let's go to the web page and then see the example data. So this is the page, and I'll leave the link to this page in the description box. This is one of my GitHub repos, by the way. So with the data, we are dealing with a Mycobacterium ostrans isolate. All right. So this data was generated using SNPEFF. So SNPEFF is used to call variants. All right. So when you have bacterial genome sequence, for example, which are haploids, you can use SNPEFF to call variant in such data sets. All right. So for variant calling, you also need a reference sequence. So this is the reference sequence that I used. So this reference sequence, you can find it in the NCBI database, but I renamed the session ID. So that is why I had to place that one here. So I'll like you to download this one instead of the one in the NCBI database. So I repeat again. So what I did with this one is that I renamed the session ID. So this one here, I renamed it. And so I have a slightly different name here. All right. So I wanted to use this file rather instead of using the one here. Okay, but the sequence is the same, the content is the same. The only difference is just the session IDs that I modify slightly. All right, so we will have to download these two files. All right, so I will start with this one, the SNP data here. So to download, just click it, and then you'll be sent to another page, which is here. And then come to this side, raw. So when you come to raw, right click, and then go to copy link. And then move to the terminal. So let's move to the terminal to download the data. So on the terminal, I'll say wget, and then I'll paste the link there. So let's execute this command to download the file. Okay, the file has been downloaded. So you can do an ls just to confirm. So we have that here. So this is our VCF file. Let's also download the reference sequence. So I'll go back and I'll come back to this side again, and then I'll click. Okay, again, let me say that the link to this page is in the description box. So click the FASTA file, and then you'll be sent to another page. And when you're here, come to raw, right click, copy the link, and then move to the terminal again, and then let's do this. Type wget and then paste the link there. So let's download this file also. All right, so it has been downloaded. So if you do an ls, you are going to find them there. So I want us to do this. Let's move the data we downloaded to another directory. So I'll do this. Let me just clear the screen. Let me do an ls first. I'll say make the data, and I'll move the VCF file there. So this one, as well as the reference sequence, I'll move all of them to data. Okay, so we have done it. So if I do an ls, I'll see my directory data, and then if I ls into it, I'm going to find my reference sequence. That's the FASTA file, and then the SNPs data itself. So now we can proceed. So let's clear the screen and continue. Okay, so let's ls into the data directory again to see the files. All right. Now before I proceed, let me say that if you are going to run SNPEFF on your data sets, on your VCF files, then I advise that you first process your VCF files, select the high quality variants, and use those for the variant effect prediction. Okay, now let's proceed. Now what we are going to do next is to normalize the VCF file that I have here. It's a recommended practice to normalize and get our VCF line splitted so that each line contains information for just one variant. All right, so we are going to use VCF to do this. We will do this in 2 steps. So I'll start with the first step. So I'll say VCF tools. I'll say norm. I'll say -m -both. And I'll say -o. That will be the output file. So that will be SNPs _AGY99. dot norm dot step 1 dot VCF. So there's the output. Remember I said we are going to do this in 2 steps. So there's step 1. Now I have to specify the inputs. All right. So the inputs, that will be data slash snips underscore agy99.vcf.gz. All right. So this is going to be the final command. Now you notice that here I did not specify the output directory as data. All right, because I want to separate the original file from what we are going to generate. So let's proceed. So let's execute this command. Perfect. So we have done that. So if some lines were split, then you find that here. So here it says total, split, realign, skipped. So total is this, then this one's 0, 0, 0. That means that split, realign, skipped, there was nothing. Okay. So if you're using your own data set, then it's likely you may see some numbers here as well. All right. Now let's look at the second step. So we will still run BCF tools norm. So I'll say BCF tools norm, and this time I'll say -f, and I'll specify the reference sequence. So that will be data slash agy99.fast-a, and then I'll specify the output. So that will be -o, and I'll say snips underscore agy99.norm.step2.vcf. Right, so the step 2, this file is what we are going to use for the downstream analysis. All right, you can also rename it, that's fine. Maybe you may want to say agy99.normalize. That's also fine. So I think we should even use this name rather. So this is going to be the output name, all right, the final name, because this is the second step, which is the last step for the normalization process. So we now have our normalized VCF. Okay, now let's do this. Let's specify the input. So the input is going to be the outputs that we generated from step 1. So that means it's going to be this file here. All right, so this is going to be the input. So I'll have to specify. So I say snips underscore agy99.norm.step1.vcf. All right, so now let's execute this command. Okay, so we have done that as well. So if you do an ls, we are going to find 2 VCF files. All right, so there's a step 1, and there's a step 2. So step 2, we said normalize the VCF, because that's the final step for the normalization steps. Okay, now we have the normalized VCF, so we can proceed. After getting the normalized VCF, you can then proceed to perform the variance effect prediction using SNPEFF. Now, the variance effect prediction, you also need a database. All right, so the database will contain information about the reference sequence that you want to use. And so it's important we check the databases that come with SNPEFF and then see if the reference sequence that we want to use is available there or not. I mean, the information about the reference sequence that we want to use as the database. All right. Now, with this data here, it was generated from a Mycobacterium ostrans isolate. All right, so with Mycobacterium ostrans, the reference sequence is the AGY99 string. All right, so I'll use this as an example to show you how to identify information or how to search through the SNPEFF database to see if the reference sequence of interest is there or not. So let's clear the screen and then do that. And then let's list the SNPEFF databases. So I will say java-jar, and then I'll say SNPEFF slash SNPEFF.jar, and then I will say databases. So this is going to list the available databases. All right, so we have information here. Okay, so this is how we do it. It's a tall list, so you can also cancel it as well. So this one lists the databases for us, but let's clear the screen and do something else. Let's do this. Okay, it lists everything for, but you may be interested in 1 or 2 organisms, all right, or maybe 3 or 4, whatever, just a small number. So instead of listing everything, you can just search for the organism of interest if you know the name. All right, so to do that, you'll still use the same command here. And this time you add your pipe command and you can say grep, and then you indicate the organism you want. All right, now let's just type this. Let's just say we are interested in this one. This is AGY99. All right, like this. Okay, so you can search by indicating the name like this to see if the organism is present. So there's the reference for the data I'm dealing with, the reference sequence, the reference string. So it's AGY99. So here, if you have your own list, then you can just search using that name. All right, this is an example that I'm showing here. So just execute this command, and then what will happen is that the databases will be listed, but then Linus will search, or let's say Bash will search for this particular term here. All right, sometimes the name will be there, but the cases may be different. For example, this one, it could be a lowercase. So to prevent all these things, you can still do this and just say -I, so that irrespective of the case, whether it's uppercase or lowercase, everything will be returned to you. All right, so you can do this, and this time, let's execute the command. So once we do that, then if the organism is present, you'll find it here. All right, so for this data here, this VCF file we are using, of course, we have the information here, right? But then let's just assume that there is no information about this organism. Then we will need to build that database. So in this tutorial, I'm going to show you how to build a custom database. So here, let me just repeat. With this particular organism, okay, there's information available in the SNPEFF database, but we are going to build our own database. Okay, we are going to build our own database and then use that. So it's just to demonstrate how to build a custom database. So for now, I want you to forget about everything here. Just assume that after searching, we did not get any hits. There was no output. So we don't have information about the organism. So we have to build our own data sets, our own database. Let me just put it that way. All right. So let's do this. Let's clear the screen and then let's continue. Let's do an ls. Yeah, okay. So this is what we are going to do. Because we are going to build a custom database, we are going to build our own database. There are a number of things we have to do. Let's go back to the page, the SNPEFF page, which is here. So it says the first thing is to configure a new genome, and then add a genome entry, and then add a codon table parameter. All right, so here we just have to add that information. And so what it means is that you have to make sure you have all this information available first, and then you can add them to the SNPEFF database. Okay, so let's go back. So this one here, step 1, configure a new genome in the SNPEFF config file, snpeff.config. So this config file can be found here. Let's just check. Let's do an ls into SNPEFF. We are going to see this one here. So this is the config file which they are referring to, or which the document is referring to. So we have to add a new genome in this file. Now you can just do a cut to display it. Let's just do it. We need to go all out. So let's just display the content here. So we have everything here like this. All right. So it's a tall list, but I just want to show you what it is. It's just a text file. You can also nano it. Let me just do it. You can say nano, or let me just use head rather. I think head will be better. I'll just do a head and then specify the file like this, and then just see the entry. So we have some entries there. Now let's do a nano. You look at it.config. You can also use vn or any text editor, that's fine. So nano, just to see the entry. So we have all the stuffs here. Okay, so this is what we have. So we are going to add an entry. Okay, so for the entries, let's check. I want you to scroll down a bit. I mean, you can scroll down. You can use other ways to scroll down to a specific line. But yeah, we are keeping it simple. So this is how a typical genome entry looks like in the config file. So you have this comment here is just a description. Then you specify the name that you want for that database or the organism or the genome. So in this case, for example, this is AG19, and you say .genome. Then you specify the name. All right. Then you can add your entry. So here it's giving a link and stuff like that. But this link, we are not going to do it. We will use a different approach here. So you specify your genome. You also indicate your codon table. All right. Let's just go back to the page here. So you specify, you add your genome entry, you open your config file, you add your genome entry, then you add your codon table parameter, which is here. Let's go back here, which is here. If, let's say, your organism has 2 chromosomes, there's a way to also specify that. I'll show that in a different tutorial. For now, we are dealing with an organism with just a single chromosome, so the approach will slightly be different. All right, but this is just how a typical entry is. But I will show you how to do that for the data we are going to use. So don't worry. But it's just to tell you how it is. Okay. So let's continue. Let's just close it. We'll come back to this. Okay. So now let's do this. So let's ls into data. Let's ls here. All right. Now I made mention that the data we are dealing with, the reference sequence is AGY99. That's the string. All right. So if, let's say, we want to build a custom database, okay, then we need to add that entry to the SNPEFF config, which I have done, by the way. So we need that, and we also need the Genbank file. So first of all, I want us to do this. I want us to first download the Genbank file first. We will come back to the entries. We will come back to doing all those stuff. But I want us to first get the Genbank file for this organism. So it can be found on the NCBI page. So this is the page where we can get the Genbank file for our reference sequence, which is here. I'll leave the link to this page in the description box. I've used this a lot. So in principle, this approach will work for small genomes. It doesn't have to be this particular organism, but if it's an organism which is small, any other bacterial genome can use it, and other organisms which are small, you can still use this approach to do it. All right, so just take note of that. So let's download the Genbank file. So on this page, come to this side, the send to, click it, then you find this coming up. So you can also click on this one here. So come to choose destination, click on file, and then when you come to format, it says Genbank. But what we will do is to download Genbank 4, this one here. This is what I'll go for. So please go for this one, Genbank 4. All right, and then click on create file. So click it, and then you can save it. Okay, so I'm going to save it in the working directory, which is variant effects. So it's sequence.gb, but I'm going to give it a different name. All right, so that's what I'm going to do. I'm going to change the name completely. So I'll just clear it and use this one. So I'll say AGY99.GBK. This is going to be the name for this file. So just make sure you also follow it like this. So AGY99.GBK. So this is the file. So I'm going to save it. All right, so I've saved it. Okay, it's done. Okay. So make sure it's in your working directory. That one, I'll leave it to you. You know your PC best or your computer best. And then let's do this. So let's do an ls, and then just make sure that you have the file there, the Genbank file. We need that. All right, so just make sure you have that. All right, so we can proceed. So now we have a Genbank file. Now let's get back to the SNPEFF config file and add our genome entry. That's what we are going to do next. So let me just quickly go over again. We are going to build our custom database. We already have our VCF. And then to build a custom database for a smaller genome, which is in our case, we will need a Genbank file, which we have. And then we are going to just follow the instructions here. Let me just go back. We are going to follow the instructions here. to do that. So let's get back to the terminal and then I'll continue. Okay. So let's do this. Let's display the config file again. I'll just say ls SNPEFF. So I will see this. So we are going to add a genome entry into this config file. That's what we are going to do next. Okay. So let's do it. So let's open it. You can open it with any spreadsheet software, VI, Nano, but I prefer to use Nano. It's straightforward, so I prefer to do that. But you can use any other text editor. So I'll say Nano, and I'll say SNPEFF.config. No, not SNPEFF. Let me just go back. I need to specify the path. All right. So the path, the config file here, it's in SNPEFF/SNPEFF.config. All right. So I have to do the right thing. All right. So I'll say Nano. I'll say SNPEFF/SNPEFF.config. Now open it. So when I'm here, I'll just scroll down a bit to this session. I mean, you can paste it anywhere, but I just want it to be organized. All right, so I'm just going to move to this section here where we have the non-standard databases, this line here. So this side here, I'll just put it here. Okay. So I'll come here and then I'll start with the description. So I'll add my hash symbol. Space, I want to follow what is here, and I'll say Mycobacterium ostrans AGY99. Right, this is what I'm going to do. Okay. So this is it. So this is the name that we are going to use, and then the next line, you specify the name of the genome. So I'll say AGY99 dot genome. Take note that uppercase A is different from lowercase a. So even if you have an entry with lowercase a, it's different from this one. So you should be careful with the names you give. All right, so this is the name. So AGY9.genome, we are adding the entry. And then space and then colon. And that space again, and then I'll just give the name here again. I'll say Mycobacterium ostrans AGY99. I will leave it like this. All right, so you can experiment with other names, but I'll just keep it simple like this. And then the next line, I'll specify the codon table. There's a bacteria genome, so it makes things pretty straightforward. So here I will also add a tab. So for the tab character, you can press the tab to get there, or let me just do it again. Or you can do this, you can just type space 1, 2, 3, 4, 5, 6, 7, 8 just to get your tab. Okay, the number of spaces for a tab character differs from one system to the other. So you have to know what to do, but I'll just do it this way. So when I do a tab, I get to this side here. So I just want it to be the same line. All right. Okay. So after that, I'll say AGY99. That's codon. Here's the spelling, the codon table. So this name here should be the same as what we define here, AGY99.genome. Should be the same. And then space, colon, space, and then we say bacteria and so notice the underscore. So bacteria underscore and underscore plants underscore plus state. This is what SNPEFF wants us to do. So this is it. All right. So here is where if you had 2 or more chromosomes, then you have to specify all of them here. But that's something I'll cover in another tutorial. Or if you also have a situation like that, you can also book a session with me and then we can just work it out. That's also fine. Okay, so now let's do this. Let's scroll down and then continue. So now we are done. This is the information we need to add. This is the entry. It's straightforward and very, very, very simple. Straightforward, very, very simple. So now we can exit and then save the changes. All right, so that is it. Okay, so now that we are done with this, there's something else we need to do. We now need to do this. We have to create a directory in the SNPEFF directory itself where we have the jar file. This one here, let me just ls into it. Okay, this directory, let me just clear the screen and then we can do it. Let me do this. So we need to create a directory called data in the SNPEFF directory itself. This is different. Alright, so in the SNPEFF directory itself, where you have the jar file, we need to place another directory and it's called data. So I'll say make that SNPEFF/data. If the directory already exists, then don't worry. But if it doesn't exist, then you have to use this command to create it. So if you do an ls into SNPEFF, you should see a directory called data. So in this directory, we'll put in our information. All right, so we have that done. Now what we need to do next is to create another directory that has the same name as the entry we made in the config file. Let me just open this. Let me say nano SNPEFF. I just want to be consistent here. So I just want to open the config file again so that we see what I'm talking about. So let's scroll down to the non-standard database. Just scroll down a bit, you'll find them here. So we are going to create a directory that has the same name as this one here, the entry we made, the AGY99, the uppercase one. So let's get back here. I will close this. I'll get back here and I'll add that. So I'll say make that SNPEFF / then I'll say data / I'll say AGY99. I'm going to create a directory. So if I do an ls into SNPEFF, I'll see my data directory. When I ls into that, I should see my AGY99 directory. That is what we need to do. Right? Now we need to do something else. We now need to copy the Genbank file. I'll just open this one here. Let me just do this. Let's ls. The Genbank file that we downloaded, this one here, we need to copy it into the AGY99 directory that we created. But when we are copying, we also have to rename it. We are not going to use AGY99.gbk. We are going to use gens.gbk. All right, so I want you to copy. So come back here and then say cp AGY99.gbk and say SNPEFF /data /AGY99 and say gens.gbk. This name is very important. So gens.gbk. Name is like this. That's what we have to do. So we are copying, but when we are copying, we also rename it. That is what we have here. Okay. So you can do that here. So let's copy it. Now if I say ls data, not data. If I say ls SNPEFF /data /AGY99, I should see my gens.gbk, the Genbank file there. All right, so this is it. So now we have completed the setup. So we now have to build the database. So to build the database, after everything has been done, you say java-jar and you specify your SNPEFF jar file. And then you say build and you specify the file type, which is -genbank. And then you say -vin for the genome version, that is AGY99. So you see that the name here, it should be consistent. All right, so that's how you do it. So once you have this command, you can execute it. So let's do that now. So if everything is okay, then you are going to see things like this coming up. Right, so you do that and then everything will be done. Okay. Now, of course, you may have some warnings coming up. Okay, so I'll go over the warnings again. So the warnings are coming up because some files were not found. Right, so we have GFF, bed, GFF. All right, so basically these files, this one has got to do with regulation elements. We also have regulation elements. We also have motifs. These are optional. But if you want to also perform annotations for regulation elements and motifs, then you can add the GFF and the embed files. Right? But you can find more information here, by the way. Just come to this page and you'll be able to get more information about that. I'll leave the link to this page in the description box. So now we can proceed. For us, we are looking at a small genome, and so the Genbank file is okay for us. Okay, so if you have a warning, you can check it out and then read about it, look it up, and if it's not anything major, you can leave it. All right, some of the warnings can actually prompt you to add extra information or additional information. So just check them and then decide whether they are worth following up or not. Okay, so now let's proceed. So let's clear the screen and then let's continue. Okay, so let's do this. Now we have built a database, but we need to still check something here. Let's just look at it. Let's do this. Let's do an ls into the database. So it's ls SNPEFF /data /AGY99. So when you ls into that directory, in addition to the gens.gbk, the Genbank file that we copied into it, you also find this, and then there's these two files. So these two files, all of them will have the extension .bin. All right. Now I want us to look at this one here, the sequence .bin. So just look at in between. So we have sequence dots, and look at also .bin. In between, we have this one here. So this one here is information that is obtained from the input file, i.e. the Genbank file. This one is the name of the chromosome or the sequence. All right. And so what we have to do is to make sure that whatever name has been given here is the same or corresponds to what we have in our VCF file. Right. But before we do, let's even just display the content here first. I think that will help us. That will clear things up. So I'll say zcat SNPEFF /data /AGY9 /sequence.cp 0003251.bin. Let's just do a tail or head. Any of them, so I'll just use tail. Right, so tail should be fine. I'll just use tail. I repeat. So if I do it, I'll have some list display, but I want us to take a look at something here. I repeat. I want us to take a look at something here. So just look at any of the lines, that has this pattern, sequence, this, that. So just look at that line, and then in the middle, we are going to see, in addition to the numbers, right, or the regions or locations or whatever, we are going to see the name of the chromosome, which will always be preceded by a colon here. All right. I repeat, in the middle of the line, right, we are always going to find the name of the chromosome. So the name of the chromosome, you always have a colon after it, and you also have some numbers here. Those are regions or locations. All right. So you need to take a note of that. So this one is the name of the chromosome, and that is what has also been indicated here. Let me just do an ls. Let's use this one here. That's what has been indicated here, right? So what we need to do is to make sure that the name here is the same as what we have in our VCF file. All right, our VCF file is here. We are using the normalized one, which is this one here. Of course, the original one is also here. Okay, it's here. Okay, but the information we have here is the same as what we have, right? Just some few stuff that we cannot find. But for the chromosome name, that one is the same here and the same here in our normalized VCF. And because we are going to the normalized VCF for the dash one analysis, we need to focus on this one, right? So that's it. So let's do this. Let's take a look at the chromosome names that are in our VCF, the one we are going to use. All right. So we are going to BCF. So we can say BCF tools, and we can say query dash, I'm just type it again. So query like this, we say dash F, I'll bring a quotes, percentage, and I'll say Chrome, and I'll say /n, and I'll specify that VCF file like this, and I'll just say, hey, let's just do this. So let's display what we have here. All right. So if you do it, you see this. So now you see what we have here. So this is CP000325, and this is CP000325.1. And so what will happen is that if you perform the variant effect prediction, we are going to find some errors coming up. Okay, because the names do not match. So we'll have something like error, chromosome not found, or something like that, because the names here do not match. You can try it later, by the way. And so what we have to do is to make sure that the names here are the same. Okay, the easiest way is to rename the chromosomes in the VCF file. All right, so that we don't complicate things. That one we can do it quickly. It's very, very simple and straightforward. All right. So what we are going to do is to use VCF tools to rename the chromosomes in this file. I'll normalize VCF. All right. So that's what we are going to do next. Okay, so to do that, you will have to create a text file which has the old name, i.e. this one, and then the new name, i.e. this one. All right. So let's do that. So let's first do this. I'll say echo. I don't need to open a text file. I'll just do it here like this. So echo, I'll bring a double quote, and then I'll just copy and paste this. It's just straightforward. I can type, by the way. I just want to copy and paste. I'm feeling lazy right now. So I'll do this space, and then I'll also copy and paste this one. So notice the space, there's a space in between. So the old name and then the new name. Then you bring your quotes again, and you can say, yes, we are redirecting it to an output file. I'll say new name. Let me just use lowercase. I'll say new name .txt. All right, this is it. And then I'm going to execute the command. So if I do an ls, I'm going to find a file here. So I'll do a cat. And I'm going to find the file there. It has the information in it. So we are going to use this information to rename the chromosomes in our VCF file. That is the normalized VCF. So let's clear the screen. Let's do an ls, and then let's continue. So to rename chromosomes in the VCF using VCF tools, we'll use this command. So we will say VCF tools annotate, and I'll say dash dash rename dash chrs, that's rename chromosomes. I'll specify the text file which has that information. That is new name.txt. And then I'll specify the VCF file. Okay, so the VCF file that will serve as our input, that is this one here. So that will be snips agy9.normalized.vcf. Right, so this is how it's going to be. And then you will specify an output. So the output is going to be -o. I'll say snips underscore agy99 underscore normalize but renamed .vcf. You can do it like this, it's fine. Okay, or you can just make it simple. I mean, you have to keep track of what you are doing, right? But I prefer to give descriptions to my names. Okay, so the output, you can give it any name of your choice, but just make sure that you can take note of that name so that you can use that for the dimensional analysis. All right, so here let's just give it another name. I think that would be better. Let's keep it simple. So I'll say snips underscore agy99 dot num, that is, or let's just do it. Let's say normalize. Let's just use the original name. That's renamed.vcf like this. Okay, so this becomes the final command to do the renaming. So let's execute this command. Okay, so we have renamed the chromosomes. All right. So now if you do an ls, you are going to find the new name, which is this one here. Right, so it is this one that we are going to use for the dance analysis. Let's clear the screen and then continue. Let's do an ls again, and then let's take a look at the chromosomes here, the names. So I'll say VCF tools, and then query like this -f percentage chrome /n. Then I specify the file, which is this one here. Okay, so now I'm going to add a pipe and I'll say head. So let's execute this command. Perfect. So now we have the chromosomes renamed. Now let's do one more check. All right. So let's ls into the SNPEFF database again. So I'll say ls, and I'll say SNPEFF /data/AGY99. So we have that here. Okay. So now we see our chromosome name, and we also see that it's the same as what we have here. These ones are in the VCF. All right. So now that the names match, we can perform our variant effect prediction. Okay. So we have to run SNPEFF to do that. And so I'll say java-jar SNPEFF/SNPEFF.jar. And then we'll have to specify some options. Now, a description of the options can be found here on the SNPEFF webpage. So I'll leave a link to this page in the description box. I will give some options as an example or as examples. And so you have to read the documentation here to see which of these options work best for you. All right. Okay, so you have to read and then decide what works best for you. Some of the options may be appropriate for you in your case. Some of them too may not be necessary at this point in time. So just read the documentation, check the discussion, and then you'll be able to identify the options that will work for you. Okay, so let's get back to the terminal and then proceed. So I will start with this option, that's an, and then I will say dash no log like this. I'll say dash no dash downstream. I'll say dash no dash upstream. I'll say dash no dash UTR. And then also say dash C to specify the config file. So that will be SNPEFF/SNPEFF.config. And then I'll need to specify the name of the database. So space, and I'll specify, so that will be AGY99. That's the name of the database. All right. And then we're also going to specify the input VCF. So space, and then the inputs will be this one here, the renamed one. So that will be snips.normalize, that's rename the VCF. All right. And then we are going to redirect the annotated variant, the information. We are going to redirect and then save to an output file. So I'll say snips underscore AGY99 underscore an.vcf. Right. Now, if you don't add this, then the results will be displayed on the screen for you. Let's even do that. I think that will be the first thing you have to do. I will come back to this. I'll just copy it. I'll paste it later. Let's just do it this way first so that you see what I'm talking about. So let's execute this command. So when you do it, then the activities will start. Right, so we'll see something like this coming up. Okay, so now everything is done. Now, if there were to be an issue, then you will have the information displayed somewhere here, or maybe in between here, or you will definitely find it. All right, but here everything is okay. So that is why the variant effect prediction has been done successfully, and there is no warning or there's no error message. All right, but what we have here, everything was displayed for you. Okay, so let's create a screen. Let's do an ls. And so what's going to happen is that we are not going to find any annotated VCF. What we are going to find rather is this HTML summary, which based on the options we gave it was generated. Okay, so what we have to do is to record the command and then add this, and then this will save the information that was displayed on the screen for us to an output file, which is a VCF. Right, so let's execute the command again, and then we can check the output. So I'm executing it now, and so it's going to be done very soon. All right, it's done. So now if I do an ls, I'm going to find the outputs VCF somewhere here. Let's check. It's supposed to be this one here. So this is a VCF file with annotations. All right, so the annotations you can read using some command line tools. You can use R, Python, or some other packages, but that's something I'm going to cover in another tutorial. And you can also check the summary here, which has information. Okay, I've given a description of this in another tutorial, and I'll leave the link to that video in the description box. So just check them, and then you can see what is happening here. All right, so that'll be all for this tutorial. And so I'm also going to make more content on variant effect prediction using other organisms, and also I'll also look at how to build custom database with the other file types. And so just come back to this channel and then subscribe, and then once those are done, you're able to see those videos. For those who also like to support this channel, there are links in there that you can use to buy me a coffee. I repeat, there is a link in the description that you can use to buy me a coffee. Okay, so I'll see you in the next session.